Okay, so today we're looking at section 3.1, which is solving quadratic equations. Up until this point, we've been manipulating quadratic functions. We've been talking about their features, like their x-intercepts, their y-intercepts, their vertices, axis of symmetry. And now in this section, we're actually going to go into solving equations involving quadratics. Now, in this section, we talk about three different methods to solve quadratic equations. That's by graphing, by square roots, and by factoring. There is a fourth method called the quadratic formula that hasn't been introduced yet. That'll be in a later section. But just know that there are four methods, and we'll talk about three in this one. So what I'm going to do is I'm going to do three different examples involving each of these methods, and then I'll do a fourth example that's sort of a challenge variation, a real-world situation having to do with this. So the first example is solve the following equation by graphing. Okay, so looking here, I've got x squared minus 2x minus 3 equals 0. So what I'm trying to figure out is what does x have to be so that when I plug it into the equation on the left, I get 0. Okay, so let's start by graphing this and see how that works out. First thing I want to do is find the vertex of this equation. And if you remember, the vertex can be found by employing the formula negative b over 2a. That'll give you the x value of the vertex. So in this case, that would be negative 2 over 2 times 1, which is positive 2 over 2, which is 1. So the x value of my vertex is 1, and to find the associated y value of my vertex, I just plug that back into the function. So it would be 1 squared minus 2 times 1 minus 3, which is 1 minus 2 is negative 1, minus 3 is negative 4. Great, so my vertex is at 1 comma negative 4. Now what I'm going to do is I'm just going to pick a couple of x values to the left of the vertex and to the right of the vertex so that I can make a graph of this function, and I'll make a table for that. So I'll put my table here, and in my equation I'll have my x and then my x squared minus 2x minus 3. So a couple to the left would be, let's say, negative 2, negative 1, 0. Couple to the right would be 2, 3, 4. So when x is negative 2, I'm going to plug that in. I get negative 2 squared, that's 4. 4 plus 4, negative 2 times negative 2 is 4, so that's 8. 8 minus 3 is 5. When x is negative 1, I get 1 plus 2 is 3, 3 minus 3 is 0. When x is 0, I get negative 3. When x is 2, I get 4 minus 4 is 0, that's negative 3. When x is 3, I get 3 squared is 9, minus 6 is 3, 3 minus 3 is 0, and when x is 4, I get 5. Great, so I'll go ahead and plot this now, starting with my vertex, which is over 1, down 1, 2, 3, 4. There's my vertex, and then from there I've got the points 0, comma, negative 3, and 2, comma, negative 3, and then I have negative 1, comma, 0, and 3, comma, 0, and then I have 4, comma, 5, and I have negative 2, comma, 5. Boom. Oops. Let's make this better. Doesn't seem to like that. Okay. There's our graph. And if you can see here, where does this function equal 0? Well, it equals 0 at our x-intercepts. And so that would be when x is equal to negative 1 and when x is equal to 3. So those are the values that would give me 0 when I plug them in for x. And that's how you can solve this using graphing. All right. Example number 2, solve using square roots. Okay, so this is not challenging. It sounds a little complex, but it's not. So all you're going to do is you're going to get to the point where you have basically something squared is equal to a number, and then you just take the square root of both sides of the equation. Okay, so let's go ahead and do that and see what that looks like in this particular context. All right, so starting with this, I'm going to add 5 to both sides of the equation. Plus 5, I get 2 times x plus 2 quantity squared equals 32. divide both sides by 2. I get x plus 2 squared equals 16. Now I'll take the square root of both sides of the equation, and when I do that, there's something important to note. You get x plus 2 on the left, it cancels out the power of 2, and on the right you get plus or minus 4. Square root of 16 is 4. But here's the critical part. When I took the square root, the right-hand side gave me a positive and a negative answer. That's super important. So whenever you have a variable on one side of the equation and you're taking the square root of both sides, you have to do plus or minus on the side that doesn't have the variable. Okay? And then from here, the next step is you would just subtract 2. So you'd get x equals negative 2 plus or minus 4. Now really what that means is there's two equations here. X equals negative 2 plus 4 and x equals negative 2 minus 4. So negative 2 plus 4 is 2, negative 2 minus 4 is negative 6. So that means our two answers here are x equals 2 and x equals negative 6. Okay, that's using the square root method. All right, and the last problem here is solved by factoring. Okay, so factoring is where you're getting two things in parentheses like this, equal to 0, and then you're using the zero product property to set each of those factors equal to 0. So what does that look like? So first thing you want to do when you're factoring, when you're solving an equation, a quadratic equation by factoring, is you want to get everything onto one side so that one of the sides equals 0. So to do that here, you'll add 12 to both sides of the equation, which will give you x squared minus 8x plus 12 is equal to 0. And then you'll draw this cross. And in this cross, you'll put your a times your c value on the top, which would be 1 times 12, because a value is 1, c value is 12. And you'll put your b value on the bottom. Okay, 1 times 12 is just 12, so I'm just going to simplify that to 12. Now you're looking for two numbers that multiply to the top number, but when you add those same two numbers, you get the bottom number. So that would be negative 6 and negative 2, and that's because negative 6 times negative 2 is 12, but negative 6 plus negative 2 is negative 8. Okay, so from here, you can say that this trinomial in green becomes the factored set of binomials x minus 6 times x minus 2. Okay, how did I get that? All I did was I took a set of parentheses and I put x and then whatever number I got on the left, x, and then whatever number I got on the right. Okay? Now that only works because my a value is 1. If my a value is not 1, there's an extra step that you have to do, which we'll talk about in a later video. Great, so from here you just use the zero product property, which says that if this times this is equal to 0, then either x minus 6 equals 0 or x minus 2 equals 0. So we get x equals 6 or x equals 2. And there's our two values that we got using factoring. In our fourth example, we have a real life situation, not a real life, it's a geometry situation that involves a quadratic. And why is that? Well, we're trying to figure out what x is, right? We don't know what the radius is. It's in terms of x. The radius is x plus 3. So I can say that my radius is equal to x plus 3. But we know the area of this circle. And if you recall from geometry, the area of a circle is equal to pi times the radius squared. So we can set up an equation that says the area, 25 pi, is equal to pi times the radius, x plus 3, squared. So all I did was substitute in the fact that the radius is x plus 3 into this equation. Now I'm just solving for x, right? So we'll start by dividing both sides by pi. So we end up with 25 is equal to x plus 3 squared. Now what do you think we might do here? The square root method. Exactly, right? So take the square root of both sides of the equation, and we end up with plus or minus 5, don't forget that plus or minus, is equal to x plus 3. And then we'll subtract 3 from both sides of the equation, which gives me x equals -3 plus or minus 5, which is two different equations, x equals -3 plus 5 and x equals -3 minus 5, which means that x equals 2 or x equals -8. There you go.